And we'll start out with an example from the homework from last week. What was that? $11,000 a year, or what was it?
Yeah.
$11,000 a year at 4% annually for 3 years. So they're only making one payment of $11,000 each year, and they want to know what will they have at the end of 3 years. So we're going to have the 11,000 times 1, 2, 3, 1 plus 0.04 divided by 1, because it's once a year. 3 years, once a year is 3 periods, so the power of 3 minus 1, close parentheses, divided by 0.04 divided by 1. Close and close. So 11,000 times 1, 2, 3, 1 plus, come on. I don't really need to put in the divided by 1, but I will. And we get 34,337.60. So that's how much they would have at the end of 3 years. Does it take it?
No.
No? We'd have to go back and see what it tries to give as the real answer. It might be just it's using the table and not giving you the table to use or something. I'm guessing you're off by pennies. So that is in the accumulation phase. We're paying in to these annuities and the money is building up. So what we want to do now is we want to look at the liquidation phase. In the liquidation phase, that's when you're drawing the money back out. The formula for how much you can draw out if you have a certain lump sum. So let's say you have $200,000 saved up for retirement. And you hope to live 12 more years. Let's say you're going to draw 3% interest. How much can you draw out each month? So we're going to start out with the $200,000. And we're going to divide by 1, 2, 3. Now this is going to change a little bit. This formula is a little bit longer than the other one. I realized the other one was long enough. For those of you with the one-line display calculator, I'm going to have to come back in a minute and show you how to adapt the formula for the one-line display. So anyway, 200,000 divided by 1 plus 0.03 divided by 12. That looks the same as before. 12 years, 12 months is 144 periods, so the power of 144 minus 1, close parentheses. Again, all looking very similar so far. Divided by, open parentheses, 0.03 divided by 12 times, open parentheses, 1 plus 0.03 divided by 12, close parentheses, power of 144, close the parentheses. So let's try this. 200,000 divided by 1, 2, 3. 1 plus 0.03 divided by 12. Close. Power 144. Minus 1. Close divided by open. 0.03 divided by 12. Times parentheses 1 plus 0.03 divided by 12, close, power 144, bless you, close, and Well, there it is. You can draw out $1,655.57 each month off of that amount. What do you think? Well, if you have the one-line display, let me show you how you'd enter that. 200,000 divided by only 2 parentheses. 1 plus 0.03 divided by 12. Close the parentheses, power of 144, minus 1, close parentheses, and hit equals. Now you're going to do times parentheses 0.03 divided by 12 times 1 plus 0.03 divided by 12, close parentheses, the power of 144, close parentheses, and equals. So you have to do that in 2 steps. Notice there's a change. Here it was divide, here it's going to be multiply because we're taking it out of the parentheses. So that is how much you can draw out if you know the lump sum. Let's do one more example of that. Let's say we're going to retire. We have $400,000 saved up. And we figure we can draw 3.7% interest. And we plan on living for another 30 years. How much can we draw out monthly? Well, 400,000 divided by 1, 2, 3, 1 plus 0.037 divided by 12, close. 30 years is how many periods? Times 12 is 360 minus 1, close, divided by open. 0.037 divided by 12 times 1 plus 0.037 divided by 12, close to the power of 360 and close. So let's try it. 400,000 divided by 1, 2, 3. 1 plus 0.037 divided by 12. Close. Power of 360. Minus 1. Close. Divided by open. 0.037. Oops. I open parentheses and take. Open parentheses. 0.037. Divided by 12. Times parentheses. 1 plus 0.037 divided by 12. Close. Power 360 and close. $1,841.13. So if you're planning on living 30 years, that's how much you can draw out. Let's say you decide, screw it, I'm going to live hard and only go 20 years. Yes. Sure. Do you want to step through this one? Gives you a headache? Okay. Well, let's take a look at this one. What if we say screw it and we go to 20 years? I'll actually do this one out the way I would do it on the other calculator. So it'll be 400,000 divided by only 2 parentheses for the other calculator. 1 plus 0.037 divided by 12. The power of 240 would be 20 years minus 1. Close and equals. So 400,000, bless you, divided by 1, 2. 1 plus 0.03 divided by 12. Close. Power of 240 minus 1 and close equals. So we got that number. Now from that number, we're going to do times 0.037 divided by 12 times 1 plus 0.037 divided by 12 to the power of 240. Close. So times parentheses, 0.037 divided by 12 times, parentheses, 1 plus 0.037 divided by 12, close parentheses, power 240, close parentheses, and equals. So if you only live 20 years, you can get $3,145.94. See the benefits of not living very long? You got to have the money first, so that's where that bank robbery comes into play. Or a lawsuit, settlement, something like that. Next time you walk into the gas station, there's a puddle on the floor. Take a fall. There you go. Stomp the snow out, or dump your glass of water. Oops, the recording was still going. Oops. I'm trying to be a positive influence on their life here. There you go. Well, let's look at the other side of this. Let's say you're going to retire, and you figure you're going to need $2,500 per month to live. And right now, you are at age 65. And you figure based on your family history, your life expectancy is to about 90. So that is 25 years. Look into your investments and you can get about 2.8% on that. So how much do you have to save up if you want to be able to draw out $2,500 per month for 25 years if you're only getting 2.8%? This is going to be $2,500 times 1, 2, 3. 1 plus 0.028 divided by 12. The power of 25 years is how many months? Say 300. Minus 1, close, divided by open. 0.028 divided by 12 times open. 1 plus 0.028 divided by 12. Close, power of 300, and close. Need me to pause for a breath so you can catch up? Okay. That'd be a good idea. I'll type it into the calculator slowly here. How's that? I got to show you a little bit different for your calculator. So it's minus 1, close, divided by open, 0.028 divided by 12 times open, 1 plus 0.028 divided by 12, close, power 300, and close. So this is saying we need $538,938.87. Probably just rounded up to $940, huh? So on the one-line display calculator, how would you enter this? Very good question. 2,500 times 1, 2. 1 plus 0.028 divided by 12 to the power of 300 minus 1, close, and equals. And now you will still divide by parentheses 0.028 divided by 12 times open parentheses 1 plus 0.028 divided by 12. Close, power of 300, and close. So this formula really doesn't change at all when you adjust for the other calculator. You just hit equals in here and then you continue typing the formula. You can just eliminate one of the parentheses at the beginning is all. Technically, there should have been another closed parentheses here, shouldn't there? Let me try it, see if that changes anything here. Nope, the calculator figured it out with it out. Okay. But yeah, there should have been another closed parentheses there technically in the long formula. Yeah.
I was just thinking, isn't there an easier way to figure this out?
What's that?
I get this.
Yep.
I got that.
Yep.
And so got
15 years? So
Yeah.
15 years, that's just 180 months.
180 months. So you go by month, not.
Well, if it's monthly payments, you gotta go by months. If it's once a year, then you gotta go by years. Depends on how many times it goes. If it's paid out every quarter, then you gotta go by quarters. You gotta go by how often it's paid out.
Okay. Thank you.
You bet.
Hold on a second, I'm still trying to figure this out.
Let's do some real life.
Real longer ones?
Yeah.
I figured.
So here's what we're looking at. You are currently. Yeah. Yep. I just leave in the full amount and just keep going with it. It might change it by a couple pennies. So let's say you are currently 31 years old. You can invest currently at 4.9%. You plan to retire at 66. Family history predicts that you will live to 86. And you figure you can invest at 3.1% while you're drawing out. Generally, while you're drawing out, the percentage goes down because you're going to invest in something safer so you don't lose the money in a volatile investment. Here's the question. If you figure you will need $2,100 per month in retirement, how much do you have to put in each month now? So we have to work backwards. We have two situations here. We have the investment and we have the liquidation, the accumulation and the liquidation. For each of those, we need to know the rate, the percent. Well, in this case, we know that for both of them. We've got 4.9% during accumulation, 3.1% during liquidation. We need to know the time. How many months? We know that for both of them. 31 to 66 is 35 years of accumulation. 66 to 86 is 20 years of liquidation. So we know the time. Then we need to know the monthly amount. For the liquidation, we know what we want that to be. Accumulation, we do not. So we cannot start with the accumulation because we don't know that monthly amount. We have to start with the one that we know all three. Rate, time, and amount. So we're starting from death, basically, and working backwards. So we're going to start from death and go back to retirement at 66. We need to find out what lump sum we need at 66 to draw $2,100 a month for that 20 years. So that's 2,100 times 1, 2, 3. 1 plus, we're going to get 3.1%, so 0.031. We're going monthly, so divided by 12. 20 years would be 240 months. Minus 1, close parentheses. Everybody with me so far?
How you get to go to
20 years times 12 months per year is 240 months. Then divided by, open parentheses, 0.031 divided by 12 times, open parentheses, 1 plus 0.031 divided by 12, close parentheses, to the power of 240, close and close. So 2100 times 1, 2, 3, 1 plus 0.031 divided by 12, close, power of 240, minus 1, close, divided by open, 0.031 divided by 12 times, open parentheses, 1 plus 0.031 divided by 12, parentheses, power of 240 again, close and close. Gives us, we're going to need $375,256.72. So that's the lump sum we need at 66 to retire. Now we need to figure out how do we get to that lump sum, where we're going to invest for 35 years to get to that sum at 4.9%. So $375,256.72 divided by, now we're back in the accumulation phase, so it's going to be slightly different again. 1, 2, 3, 1 plus point, was it 4.9? Yes. 0.049 divided by 12, close to the power of 35 years is 420 months, minus 1, close, divided by open, 0.049 divided by 12, close and close. That is it. Remember, we're in the accumulation phase now, so we don't have that extra term over here. So take that number divided by 1, 2, 3. 1 plus 0.049 divided by 12, close, power of 420, minus 1, close, divided by open, 0.049 divided by 12, close and close. $337.71. So if you have 35 years to invest, you only need to invest about $340 a month so that you can retire for 20 years on $2,100 a month. At those interest rates. If it was higher rates, of course, it comes out even more significantly. What do you think? Confusing? Think it works?
Well, they know it works.
Yeah, it's just you guys solve two different problems, put them together. Yep. So I'm going to give you guys one of these to try on your own, and I'm going to give you about 10 minutes to work on it. So let's see what happens here. You are now 25 years old. You can invest at 6.2%. You'll retire at 65 years of age. To save words, I'm going to say you're going to die at 90. Your retirement investment, you can invest at 3.4%. If you figure you are going to need $3,000 per month in retirement. Tell me how much you need to put away every month from 25 to 45. I'm going to pause this. Okay, so I wrote out the formula for the first part here in the way that we would do this if we were using the one-line display calculator. We had to do it in two pieces. So 300, or 3,000, I should say, times 1, 2. Again, if you can do this all at once, you have 3 parentheses there, but I'm doing it for those that have to break it into 2 pieces. 1 plus 0.034 divided by 12. Close to the power of 300. Minus 1, close parentheses, and hit equals. Now that number, something don't look right there. Let me try that again. Okay, that's fine. We'll hit equals. Now we have to divide by, parentheses, 0.034 divided by 12 times, close parentheses, 1 plus 0.034 divided by 12, close parentheses, to the power of 300. And arrow out and close. And there we go. That is not correct. Something went wrong. Let me try it again. See what happened.
What should the numbers be
I couldn't even say shooting from the hip here. So 1 plus 0.034 divided by 12, close to the power of 300, minus 1, close. Okay, that's looking okay. Divided by 0.034. Oops, we got to put in the parentheses first. Parentheses, 0.034 divided by 12 times 1 plus 0.034.
We got the parentheses.
Is that what it was?
Time. Oh, we just didn't say it.
Okay. 12, close, power 300, and close. That's better. $605,722.29. 605,722.29. That is how much we need at age 65 to get to 90 with $3,000 a month. Yep. Yep. Now we're going to put that number back in to figure out how much we have to put in. So it's going to be divided by 1, 2. Again, I'm going to use the formula for those that have to break it into 2 pieces. So it'll be 1 plus. Now our rate is 6.2% while we're investing. So 0.062 divided by 12 to the power of, now that is 40 years between 25 and 65. So we're looking at 40 years of investment. So 40 years is 480 months minus 1, close, equals. So we'll do that first. Divided by 1, 2. 1 plus 0.062 divided by 12 to the power of 480 minus 1, close parentheses. So now from there, we do times .062 divided by 12, close parentheses, times, parentheses, .062 divided by 12, close parentheses. $288.03. So if you put away $290 a month for 40 years, you can retire with $3,000 a month for 25 years. That's not bad. That's less than a car. That's about a car payment there. If you, that's about a $15,000 car payment on a $15,000 car. So if you just don't ever have a car, you're good. Right? Let's look at the other side of this. Let's say you've started your job. You are 31. You can invest at 7.1%. And you figure you can afford right now and probably forever and ever $250 per month. So that's what you're going to invest. It's $250 a month from 31 until you retire at 64. You want to retire. So we are going for 33 years. Times 12 is going to be 396 months. And again, just because it's the shortest way to write it, you plan to die at 90. So that is 26 years. Times 12 months. 312 months of life after retirement. So the question is, this $250 a month, and if you can earn, let's say you plan to earn 4%, we'll keep it simple, during retirement. Let's figure out how much will you get every month in your retirement. Let's start out. I'm going to do the long formula this time. So 250 times 1, 2, 3, 1 plus 0.071 divided by 12 to the power of 396 minus 1 close divided by open. 0.071 divided by 12 close and close. So 250 times 1, 2, 3. 1 plus 0.071 divided by 12. Close to the power of 396 minus 1. Close. Divided by open. 0.071 divided by 12. Close and close. So you're going to have 394,681.08. 394,681.08. Because this is during the accumulation. We're paying in. Now we're going to draw back out at 4% for 312 months. So we're going to take that number right there divided by 1, 2, 3. 1 plus 0.04 divided by 12 to the power of 312 minus 1, close, divided by open. 0.04 divided by 12 times, parentheses, 1 plus 0.04 divided by 12, close to the power of 312, close and close. So, there's a mouthful. Divided by 1, 2, 3. 1 plus 0.04 divided by 12, close, power 312, minus 1. Divided by open, 0.04 divided by 12 times open, 1 plus 0.04 divided by 12, close, power of 3, 12, close, close, enter. You get $2,036.75. So there you go, $250 a month right now will turn into just over $2,000 a month in your retirement. It's not bad. Any questions? How many of you feel like you could maybe do those formulas on your own? How many of you feel like you have no hope of doing those formulas on your own? Okay. Let's take our break. If you want to go, there will be a new homework due next week. Of course, there will be a test next week as well, and then there's a new quiz due tomorrow, Wednesday, at 11:59 p.m. We'll take our break. If you want to, we'll come back and I will do some more examples after break to help you figure out how to punch these in. Okay? Yes.